welcome back to the deep dive. You know that feeling when you look at a perfectly engineered digital experience, an app, a website checkout flow, a seamless onboarding sequence, and you just assume that a brilliant engineer somehow coded that perfection into existence?
Yeah,
The truth is that success was built on a foundation of, well, boxes, arrows, and messy sketches.
exactly. Before a single line of high-cost code is written, there is a fundamental, intensely strategic phase that determines whether a product succeeds or fails.
And we are talking about the high-leverage, low-cost blueprints of the digital world.
Exactly. Today, we are pulling back the curtain on the essential thinking tools that every product manager, every stakeholder, and every serious engineer needs to master.
Okay.
We are focusing on the strategic power of low-fidelity or lo-fi wireframes and flows. These are not merely artifacts for the design team to produce.
No.
They are the core documentation used for defining requirements, aligning cross-functional teams, and most importantly, mitigating massive technical and financial risk before large investments begin.
Our mission today is to give you a deep shortcut into this foundational stage. We're going to clarify exactly where these low-fidelity tools sit in the larger product development process, distinguishing clearly between a simple wireframe, a conceptual user flow, and the powerful hybrid known as a wire flow.
And crucially, we're going to show you how to use these artifacts as tangible research tools, turning that vague feedback you always get into concrete design solutions that drastically improve user experience.
Because if you can't sketch it out simply, if you can't map the intended logic using just boxes and arrows, you probably can't build it successfully.
We really can't.
Okay, let's unpack this. By first setting this strategic stage and looking at where these elements fit into the larger product lifecycle, because context is truly everything in product work.
It really is. When we approach product development, we're moving through various phases, often described in an iterative loop. And to understand the strategic weight of lo-fi design, you need to know which phase it really dominates.
Right.
We break the process down into 4 interconnected zones.
Okay, so the first zone is discovery. This is the pure understanding phase. You are figuring out who your users are, what problems they genuinely have, and the real-world context they operate in.
Right. And our sources emphasize classic research here. Deep user interviews, field studies, looking at current analytics, and running structured surveys.
So at this point, you are a detective gathering evidence, not a builder designing a solution.
Exactly. Discovery gives you the raw materials, the pain points, and the opportunities. That information then moves into the second zone, definition.
This is where the intellectual heavy lifting happens.
It really is. You synthesize those raw insights into something actionable, defining precise user needs, framing the jobs to be done, articulating crystal clear problem statements.
And critically, establishing measurable success metrics.
Yes. This zone lays the intellectual foundation for everything that follows. You have decided what success looks like.
And now we transition directly into the third zone, which is the epicenter of today's deep dive, design.
Sweet spot.
The design phase is where you take those defined problems and begin exploring solutions. But, and this is the key insight, it starts low fidelity. We use wireframes and flows to rapidly explore different solution variants, validate those core concepts quickly, and refine them.
And only once that structural logic is validated do we move to the expensive, resource-intensive stage of high-fidelity designs and functional prototypes.
Right. And finally, that brings us to delivery.
And that's the execution phase. Building the actual product, running final, detailed usability tests on the hi-fi version, releasing it to the world, and using continuous analytics and iteration to judge if the delivered solution actually hit the success metrics defined back in Zone 2.
Okay, so we positioned lo-fi squarely in Zone 3, the early stage of design. But I have to ask the critical PM question here.
Go for it.
If we are striving for speed, this idea of getting to minimal viable code as fast as possible, why should a product manager stop their forward momentum to draw boxes and arrows? Sell me on why stopping to sketch is actually faster than just writing detailed specs and jumping straight into building.
That is the perfect question because it cuts right to the heart of the leverage principle. We aren't sketching for beauty. We are sketching for clarity and risk reduction.
The risk reduction, okay.
Think of the cost curve. Fixing an error in the requirements phase, drawing a new box on paper costs almost nothing.
Right.
Fixing that same error when it's deployed in production costs orders of magnitude more developer time, bug fixes, lost customer trust, operational support hours.
So lo-fi design is the highest leverage risk mitigation tool you possess.
It is, absolutely.
I see. So Use the tool strategically. I want to emphasize, the source materials is very clear on this. The PM is not necessarily the sole designer.
No, not at all.
Your job is to drive strategy, resource allocation, and clarity. Lo-fi tools are your heavy artillery for that, and there are, three main ways you use them.
That's right. First, they are vital for clarifying requirements and scope. A poorly articulated feature request leads to scope creep and rework. It just does.
Always.
If you, the PM or the design partner, can't draw the sequence of actions or the screen structure, the requirement will be vague. A wire flow turns abstract requirements like allow the user to register into concrete steps.
You're defining every success, failure, and edge case the engineering team must address.
Precisely.
And second, the benefit we see most often in highly functional teams, stakeholder alignment. If you present a beautiful, polished interface, stakeholders marketing, legal, sales immediately start critiquing the visual details.
Well, they love it. They bite the color palette.
Right. But if you present a grayscale box and arrow flow, they are forced to engage with the underlying structural logic. They have to focus on function and process, not aesthetics.
And it forces everyone to align on what the product will do before the team commits serious resources to visual polish or coding.
That alignment is non-negotiable for project success.
It really is. And third, lo-fi artifacts are how you make research concrete and indisputable. It's not enough to say, our research showed high drop-offs at registration.
You have to show it.
You have to show it. You use the as-is flow diagram to visually demonstrate the pain point, complete with data annotations. Then you present the to-be flow saying, here is the current flow where 40% of users fail, and here's the proposed flow, which removes 2 steps and introduces inline validation to fix it.
You've instantly turned academic research into a tangible, measurable path forward.
Exactly.
If we connect this back to critical thinking, the very act of sketching forces you out of ambiguity. You can't hide a confusing interaction loop behind a paragraph of text.
You really can't. Lo-fi design forces absolute focus on function over form, which is crucial for solving the fundamental logical problems when they are cheapest and easiest to change.
So you're checking that the engine works efficiently before you even consider designing the car body.
That's the perfect analogy.
So we understand the strategic placement. Now let's nail the tactical definitions. We're talking about 3 distinct conceptual tools that, while they overlap, serve very different purposes.
Yeah, we need to be crystal clear on what each one is and, more importantly, what specific design question each one is best suited to answer.
Let's start with the wireframe.
Okay, the wireframe. As you mentioned, it's the skeleton of a single screen or page. The definition is simple. A simplified layout showing structure, content hierarchy, and basic interactions.
And the critical part is that it is not the final visual design.
Absolutely not. It's stripped back minimalism.
We're talking boxes, lines, placeholder text, sometimes called Greeking or lorem ipsum, but ideally it should be contextually relevant text, right?
Right, something that gives a sense of what will be there. And then just simple geometric shapes for buttons or images. The focus is strictly on what's on the screen and where it resides.
So where's the primary navigation? Where's the main call to action? How is the content prioritized?
Exactly. We ignore branding, colors, final typography, and fancy imagery. Whether you sketch it on paper or in a low-fidelity template within a digital tool like Figma, the goal is clarity of structure.
And here's how to think about its utility. What specific questions do wireframes answer? They deal only with the immediate screen context and content, for example.
Like, considering this is a high-traffic landing page, which information blocks must be above the fold?
Or, we need the user to complete this complex 4-field form. What is the optimal sequential grouping of those fields?
Or, and this is a big one, if a user fails a security check, where exactly should the error message appear so they cannot miss it, and what language should it use?
So it's all about the content and structural layout of that single moment in time, ignoring the journey before or after.
Precisely. Now, if the wireframe is the static portrait of a moment, the user flow is the dynamic screenplay.
The journey map.
Exactly. User flows, or task flows, define the step-by-step sequence of actions and decision points a user navigates to achieve a specific goal, whether that's registering for the service or successfully booking a multi-stop itinerary.
These flows are purely about logic and movement, and they must contain 4 essential components to be complete. First, you have the entry point, right? Where does the user begin this task?
Is it from an email link, a banner ad, or a deep link from another part of the product?
And then second, the steps.
Right. These capture the interaction itself, which includes both the user's action, like clicks continue, and the system's corresponding response. System validates input and loads step 2.
And third, the decisions and branches. This is where the flow gets interesting and complex. You're charting the crucial split points.
Success versus failure, choosing option A versus option B, or when a user encounters a mandatory intervention like a password reset, you have to map all of that.
And finally, the exit point. This confirms the goal was achieved. The confirmation screen, or the point where the user successfully abandoned the task and returned to a safe state.
What's crucial to understand is that flows, in their most abstract form, do not show specific screen layouts. They might just be labeled boxes that say, user enters credentials. If credentials valid, redirect to dashboard.
It's a high-level logical map,
Right.
often created before the first wireframe is even sketched.
Yes.
Here's where it gets really interesting, because we combine the structural clarity of the wireframe with the sequential logic of the user flow. We introduce the wire flow.
The hybrid solution.
Wire flows are the hybrid, and the Nielsen-Norman group, the usability experts, provide the defining clarity here.
NN characterizes wireflows as a design specification format that effectively merges simplified wireframe-style page layouts with a simplified flowchart-like way of representing interactions.
So it's the crucial bridge you need when abstract logic, the flow, must be tied directly to concrete screen context, the wireframe.
Exactly.
So why do we need this hybrid? When do you use it?
You use wireflows when the navigation itself or the content on a specific screen fundamentally changes the flow. If an abstract box labeled Step 3 is not sufficient.
And you need to show the engineering team how the user gets from the input field on screen A to the confirmation message on screen B.
You use a wireflow.
This makes wireflows incredibly valuable for complex multi-step scenarios like detailed configuration wizards, complex checkout flows with mandatory redirects, or multi-factor authentication sequences.
Absolutely. Wireflows allow you to communicate not only the structure of each step, but also the navigation links, the required system feedback, the conditional logic. It's all there.
So this early stage, just sketches of key screens linked by arrows labeled with the specific action, like tap submit button, are enough to prevent massive misinterpretations down the line.
It's the ultimate conversation artifact for complex logic that demands visual context.
Okay, let's talk about the mindset shift.
Hmm.
If we could build things perfectly the first time, we would, but the reality is iteration is inevitable.
It is. The strategic importance of staying low fidelity early on is one of the most cost-effective habits a product team can adopt.
As product managers, we are trading off speed, quality, and cost constantly. Low fidelity work seems to optimize all three simultaneously.
It does. First, there is the obvious benefit of speed and iteration. Lo-fi is fast to create and, critically, fast to discard.
Right. If you spend 10 minutes sketching 3 variants of a login flow, and 2 of them are fundamentally flawed, you toss them instantly.
And contrast that with high-fidelity work. If a designer spends 20 hours polishing a hi-fi prototype of a flawed idea, there is enormous pressure from the team and stakeholders, and often the designer themselves, not to scrap it.
The sunk cost fallacy.
Exactly. Lo-fi ensures you can explore 5 distinct solutions in the time it takes to refine one polished bad idea. The speed encourages extensive exploration of conceptual alternatives.
The second reason is essential for productive meetings,
Yeah.
reducing bike shedding.
Oh, this is a big one.
For listeners unfamiliar, the term comes from an anecdote about a committee that easily approved an expensive, complex nuclear reactor design, but spent hours debating the materials and color of the bike shed outside the facility.
It's human nature. If you show a beautiful interface with brand colors, polished typography, and shadow effects, stakeholders immediately fixate on those visual details. They feel qualified to judge the shade of blue.
And this just derails meetings. It consumes hours debating subjective aesthetics that should be addressed much later.
But if you walk into that meeting with a grayscale wire flow composed entirely of boxes labeled Form Field and Primary Button, you effectively remove the visual distractions.
So stakeholders are forced to engage with the structural integrity, the content priority, and the logical steps.
Right. The debate becomes, should we ask for their phone number before or after the credit card details? This keeps the conversation disciplined and focused purely on function, not form, maximizing the value of stakeholder time.
And third, it's about cost-effective testing.
Yes. You do not need a fully functional coded interface to test the underlying logic. Lo-fi prototypes, whether clickable Figma wireframes or even paper sketches, can be used in early usability testing.
So you can find out if the basic flow logic is fundamentally flawed before a single dollar of engineering time is committed to front-end development.
You're allowed to fail safely and cheaply.
And finally, accessibility. The required skill level for lo-fi is low. Anyone can sketch boxes and arrows.
Right. This democratizes the design conversation, inviting crucial input from PMs, engineers, legal counsel, and researchers, ensuring the design is feasible and compliant, not just pretty.
So the mantra of low fidelity is rough, but not sloppy. A good lo-fi wireframe or wireflow must still be clear and structured.
That's right. There are specific must-haves that ensure the artifact communicates intent effectively.
So on the inclusion list, first, always ensure a clear page or screen title. Label your frames. Check out delivery details, V2, or user profile empty state. Context is vital.
It is. Second, include all key content blocks. Use placeholders to denote where complex elements will sit, a block for the list of search results, a placeholder for the hero image, or distinct boxes for form fields and required legal text.
Third, identify your primary and secondary actions clearly.
A main button should look substantially different from a link or a secondary back button, even if they are both just gray boxes. It establishes the hierarchy of action.
And here is a crucial point often overlooked in early sketches.
Yeah.
You must account for states. A screen is dynamic.
So true. You need to show the important states. What does the screen look like when it's loading? What does it look like when the user has no data, the empty state?
Or what does it look like when an error occurs? If you're designing a search feature, you must show the search results page, the empty results page, and the loading state.
And most critically for the transition to engineering, you need annotations. These are the short notes that explain behavior, system response, or conditional logic that the static visual layout cannot convey.
So an annotation might read, upon successful submission, the system should show a brief toast notification before redirecting to the success page. Exactly. Or, this field is mandatory and should trigger inline validation after the user leaves the field. These notes transform the diagram into a true specification artifact.
Conversely, what do we exclude? The aesthetic distractions.
All of them. Keep out brand colors, sophisticated final typography. Grayscale is your friend, and do not spend time obsessing over pixel-perfect alignment or spacing.
And use realistic but not final placeholder text. So if a user needs to enter a comment, don't use lorem ipsum. Use something representative like, please enter your comment here, maximum 500 characters.
Right. Keep the text relevant enough for context testing, but don't waste hours wordsmithing the final marketing copy at this stage.
And this fidelity principle applies equally to flows, right?
It does. As we discussed, a flow can be highly abstract, just labeled text boxes showing steps. The PM should always choose the lowest fidelity necessary to answer the immediate design question. So if the question is purely, what is the fastest sequence of steps to reset a pathword, then abstract boxes and arrows are perfect.
Right. But if the question becomes, does the placement of the forgot password link on the login screen effectively guide users into the reset flow, and what information do we ask for on the first screen of that flow?
And you need the higher fidelity of a wire flow.
Exactly. You still use simple sketches, but you link the actual screen structures together. This mid-level fidelity is often the sweet spot for communicating complexity to engineers, as it answers both the logical sequence and the visual context, but avoids the time sink of high-fidelity design.
So the decision is always efficiency.
Oh.
What's the cheapest way to document the logical intent?
That's it.
Okay, if we connect this to the bigger picture, the reason we bother with all these definitions and principles is to facilitate the single most valuable strategic exercise a product team can undertake. Defining the gap, or the delta, between the painful current reality, the as-is experience, and the desired improved future the to-be experience.
And you must rigorously map the chaos first.
The goal of mapping the as-is flow is total honesty. We need to capture the messy reality, the workarounds, the frustrating loops, the unexpected errors.
All of it. And crucially, this map cannot be based on managerial assumptions. It must be grounded entirely in hard evidence.
That evidence requires synthesizing multiple data inputs.
Yeah, we typically merge 4 crucial types of data. First, quantitative data. This is your analytics, your funnel analysis. It tells you where users are dropping off.
So 60% of users leave at address validation, that kind of thing.
Exactly. It tells you the most common, successful, and unsuccessful paths.
Second, behavioral data. This is data from usability testing, observing users trying to complete tasks or session recordings. This shows how people actually behave.
which often differs wildly from how the system is designed to work. For example, quantitatively, you see a high drop-off. Behaviorally, you see users entering the wrong address format repeatedly because the validation message is confusing.
Ah, I see. Third, attitudinal data.
Right. This comes from customer interviews, support tickets, direct feedback. These inputs provide the emotional context and the recurring complaints, like,
I keep getting stuck at the payment stage because I can't figure out how to change my shipping address without restarting the entire checkout process.
you've heard that one before.
Many times.
Mhm.
And fourth, the expert review. This is where you, the PM or the design lead, conduct a heuristic evaluation.
Right. You're reviewing the existing flow against established usability principles like consistency and error prevention. For example, an expert might note, the system uses 3 different styles of error messages across these 5 steps, violating the principle of consistency.
So combining these 4 inputs gives you an undeniably realistic picture of the current pay-no-detail data-backed diagram of the user struggle.
Exactly.
Let's walk through the steps to sketch this messy reality, maybe using a checkout flow example. First, you have to define a single, narrow user goal.
Right. Focus on one persona and one path. A first-time guest user buys a single digital product using a credit card on the desktop site. Be specific.
Second, identify all possible entry and exit points. Where can they start? A product page, a search ad, the shopping cart.
Then, list the steps of the idealized happy path, the smoothest journey if nothing goes wrong. View item, add to cart, start checkout, enter details, pay, confirmation.
Third, and this is where the as-is becomes valuable, you add the real-world branches and loops. This is the complexity you found in your data.
Right. What happens if the user attempts to log in but fails 3 times? That's a forgotten password branch. What happens if they enter a coupon code that requires a higher minimum purchase? That's a loop back to the cart.
What if the address validation fails? They might abandon, or they might try re-entering it in a different format. You have to diagram the reality, not the ideal.
Fourth, and this is crucial, you must capture the pain points and evidence right on the diagram. Use clear annotations.
Don't just draw the step. Point an arrow to it and write 45% drop-off rate here, funnel data Q3, or support tickets spike here, users report confusing redirect attitudinal data.
You are establishing an objective baseline for future comparison.
And finally, fifth, mark any existing system constraints. These are the hard dependencies you can't easily change, at least not in the immediate product cycle.
Right. Our payment provider mandates a 3D secure redirect page, which we cannot eliminate. Or legacy database restricts username length to 10 characters.
So this keeps your proposed design pragmatic. By the end, you have an honest, annotated map of the current struggle, the Grand Canyon of product frustration you now have to bridge.
That's a great way to put it. Now that the as-is reality has been established, you can begin designing the proposed-to-be experience.
And crucially, this proposed flow must start from the problems and constraints identified in the previous step, aiming for measurable goals.
Exactly.
So let's take a concrete example. If the as-is mapping showed a huge drop-off because of a mandatory account creation step before payment,
The goal for the to-be flow is obvious. Enable guest checkout and reduce the number of discrete steps from 6 screens to 3 wire flows.
or if the problem was vague errors, the goal is to implement real-time, inline validation, and clear error messaging.
To systematically shape a better flow, we use established usability principles, or heuristics, to stress test the proposed logic before we draw the final wireframes. This ensures your new flow isn't just different, but structurally better.
For example, let's apply the heuristic of visibility of system status. If your as-is flow was a confusing sequence of pages with no context, your to-be flow must incorporate visible progress indicators.
A bar that clearly states step 3 of 5, payment. The lo-fi wireframes for this flow must include the sketch of that progress indicator and an annotation detailing how it updates.
Similarly, the principle of user control and freedom is applied. If the current flow forces users to hit the browser's back button and potentially lose data,
The to-be flow must include clearly defined persistent back and cancel options, labeled appropriately, giving the user agency to escape without penalty.
then crucially, error prevention and recovery. Instead of waiting for the user to submit a form and then throwing a page-level error message.
The to-be flow must incorporate inline validation. In your lo-fi wire flow sketch, you show the input field, and then you show the error state of that input field with an annotation. Real-time validation on card number. If input is not 16 digits, show inline error immediately.
Applying these principles leads to immediate, practical improvements visible in your flow documentation.
Yeah, you might combine shipping and billing details onto one page with an optional checkbox, reducing screen load time and cognitive load. You build explicit confirmation screens, ensuring the user is confident the task is complete.
And finally, just like the as-is flow, your proposed-to-be wire flow must be an active, living project artifact.
hmm You must annotate decisions, risks, and open questions. Highlight the specific changes from the old flow. Call out your technical assumptions. Assumption, we can decouple address validation from the legacy system.
And flag crucial open questions for team review. Dependency. Does legal require a mandatory opt-in checkbox for marketing emails at this specific step, or can we make it optional?
This transforms the diagram into a dynamic plan ready for team consensus.
Let's get tactical now. We need to be fast, flexible, and collaborative. The choice of tool depends entirely on the stage of ideation you are in.
Right. It's not about choosing one tool over another permanently. It's about choosing the right tool for the moment of thought.
Let's start with paper.
For very early stage ideation, collaboration, and rapid sketching, paper is unbeatable. It is instantaneous, cheap, and has zero psychological commitment.
And if you are stuck, drawing on paper removes the cognitive load of navigating software menus.
It really does. This is the perfect medium for collaboration exercises, particularly crazy eights.
This is a rapid workshop method where the entire team PM, engineer, designer takes a blank sheet of paper, folds it into 8 sections, and sketches 8 different conceptual solutions for one key screen.
Like the shopping cart page.
In 8 minutes. The sheer speed forces them to focus on unique structure, not polish. The goal is quantity over quality, maximizing the chance of a breakthrough idea.
If you are leading one of these sessions, a few tips make a huge difference. First, use thick black markers.
Why thick marker?
This forces simplicity. The thick line prevents the team from drawing minute details like tiny icons or pixel-perfect spacing. They have to focus on main content blocks.
Ah, I see. Second, keep one main flow or concept per sheet to avoid creating a confusing, tangled web of arrows.
And most critically for the product process, you must bridge the gap between paper and documentation. As soon as the session ends, photograph and upload those sketches.
Put them in a central design repository, Figma, Miro, wherever, and link them to your requirements or user stories.
Exactly. The sketch represents the thinking, but the photo is the permanent documentation. If you don't document it immediately, that valuable thought will be lost when the whiteboard is inevitably erased.
So true. Okay, so once the core concepts are validated and the team agrees on the direction, say, you've picked the best 2 flows from the Crazy 8 session, it's time to move to digital tools like Figma or Sketch.
Right, for refinement and stability.
I want to revisit a point from the critique here. When we move from paper to Figma, how do we prevent the team from immediately defaulting to hi-fi design out of habit? What practical guardrails does a PM set to keep things strictly low fidelity?
That's a vital question. The guardrail is standardization. Within Figma, the design team should create a dedicated, shared lo-fi wireframe library.
So it's a controlled environment.
It is. This library only contains simple grayscale shapes, restricted typography, usually a single simple font and basic reusable components. This forces the use of a controlled style. You maintain that lo-fi wireframe style by removing access to brand assets.
The huge advantage here is that you can create true reusable components. Simple grayscale buttons, input fields, and navigation bars become master components.
Right. So if you decide that the primary action button needs to move from the bottom right to the top left across 20 linked screens in your wire flow, you update the master component once, and all 20 screens update instantly.
This maintains the speed and flexibility that paper offered, but adds the necessary stability for refinement.
And digital tools truly shine because of their prototyping capabilities. You can use Figma's prototype mode to link frames and simulate the flow. You can run through the user experience exactly as a user would.
Clicking through the journey path. This helps the PM internalize the pacing, identify missing steps, and ensures the flow feels logical, all without needing any functional code.
Exactly. And finally, these tools are superb for organization. You can label and organize flows directly on the canvas. You can clearly define and organize variants, labeling them Flow A guest checkout V1 versus Flow B logged in checkout with coupon logic, ensuring crystal clear communication about which path the engineering team should prioritize.
Okay, so this raises an important question.
Right.
We've defined the problem with the as-is flow, and we've meticulously designed the improved-to-be flow and wireframes. But how do we actually know that the new design is superior?
The answer lies in using the lo-fi artifact itself directly in validation and research, closing that feedback loop quickly and cheaply.
This is where we save massive amounts of time. Lo-fi designs are integrated into UX research methods well before they ever land in a development sprint.
Right. The goal is to catch fundamental errors when they are literally rectangles on a screen. We leverage 3 primary validation methods at this stage. First, prototype or concept testing.
This involves setting up your paper sketches or your Figma click-throughs as a simple, non-interactive or lightly interactive prototype.
Then you recruit real users, give them specific tasks, complete this checkout using this simplified flow, and you observe their attempts.
And because the fidelity is low, users naturally focus on the function and flow logic, not the visual polish.
Exactly. If a user says, "I don't know where to click next," that's gold. That tells you the labeling, the structure, or the logic is broken, and you fix it with 5 minutes of sketching, not 5 days of debugging.
What's the second method?
Second, we highly recommend pluralistic walkthroughs. This is a powerful collaborative method. It involves gathering a diverse group, a user representative, the designer, the PM, and a lead engineer to step through a scenario together using the lo-fi flows.
So the process is structured. One person reads the scenario aloud. The user is trying to apply a coupon they received in an email. And the group, physically or digitally, steps through the flow, screen by screen.
And each person, including the engineer, silently notes any issues they foresee, usability problems, technical constraints, or logic flaws.
So by walking through it together, issues are discussed as a group in real time, building immediate, shared alignment, uncovering technical constraints, and validating the feasibility of the flow early on.
It's incredibly effective. And third, heuristic evaluation. This is where experts, usability specialists, experienced PMs, or designers review your proposed lo-fi flows against usability heuristics, ensuring the new design adheres to principles like consistency, minimal memory load, and error prevention.
And the massive benefit here is that this is done before you invest heavily in the time-consuming process of high-fidelity design. You are catching fundamental flaws when they are cheapest to adjust.
That's the whole game.
So, after all that testing, what's the ultimate outcome for the product manager? How does the feedback loop translate into product decisions?
Well, the feedback from these low-fidelity testing methods drives critical business decisions. First, it allows you to decide if a flow is good enough to proceed. If testing shows fundamental confusion or a new major blocker, you iterate again in lo-fi, avoiding a costly failure later.
Second, it helps you prioritize which edge cases to support immediately versus later.
Right. You might discover that while only 5% of users encounter a specific error, like trying to use an expired gift card, the resulting frustration is so high that addressing that specific error state immediately becomes a high priority.
I see. And finally, the validated flow, complete with all those detailed annotations and state definitions, becomes the foundational document.
That allows you to refine and lock down requirements and acceptance criteria for the engineering team. It ensures they build exactly what the user needs and what the business intends, preventing ambiguity from creeping into the code base.
This deep dive has shown that immense, often underestimated value that exists in the simplicity of low-fidelity design.
Absolutely.
Lo-fi wireframes and flows are not optional design fluff. They are the engine of clarity, speed, and alignment, providing a clear, evidence-based path from a painful, messy, as-is experience to a thoroughly tested and improved-to-be solution.
We've covered the strategic placement, the critical definitions, and the practical application. For you, the learner, who wants a practical mini playbook to start leveraging these tools immediately, let's run through the checklist one last time.
1. Pick a single high-value user goal. What is the one thing users struggle with most?
2. Map the current flow, the as-is starting from the most common entry point. Sketch every step, every loop, and every painful branch. Critically, annotate it with real pain points and evidence, such as users confused here or 40% abandonment rate.
3. Summarize the key problems that mapping revealed. Is it too many steps? Ambiguous copy? A hidden or unavailable action?
4. Sketch alternative proposals, the 2B. Try 2 or 3 variants using quick paper or lo-fi digital wire flows, ensuring they systematically reduce the friction points you identified.
5. Review the current versus the proposed flow with your cross-functional team, using the diagram to capture risks, technical dependencies, and open questions directly on the artifact.
6. Choose the candidate flow and turn it into a simple, clickable prototype for immediate testing, whether internal with your team or with real users.
That's a great summary.
The power of low-fidelity design isn't just in what you manage to sketch, but in the chaos you prevent. Think about the thousands of hours saved by catching fundamental errors. A misplaced button, a confusing logical loop, or a forgotten error state on paper or in grayscale, rather than fixing a buggy, hard-to-change feature deep in the production code months after launch. With that concept of high leverage in mind, what common frustrating workflow in your daily life, digital or physical, is ripe for an as-is analysis right now?
That is a brilliant final thought to leave you with the high leverage question. Get sketching, start aligning, and thank you for joining us for this deep dive into the structure and strategy behind great product design. We'll see you next time.